As building construction increases with population growth, the increase in energy use and its associated costs has caused buildings to become tighter and their heating, ventilating, and air conditioning system, commonly called HVAC systems, to be more efficient and more costly. Good building indoor air quality requires that the buildings receive adequate amounts of clean outdoor air for ventilation. HVAC duct systems are needed to supply and distribute the clean ventilation air throughout the buildings, and the use of spiral duct for these HVAC systems can offset some of the ever-increasing costs of building construction. The many advantages of round spiral duct prompted many spiral duct manufacturers to form SPIDA, the Spiral Duct Manufacturers Association, to promote the advantages of spiral duct to the HVAC industry. SPIDA also has donated funds to the American Society of Heating, Refrigeration, and Air Conditioning Engineers, known as ASHRAE, for joint research projects to confirm engineering data for spiral duct and spiral duct fittings. Although many HVAC design engineers and building owners know the advantages of using round spiral duct, many do not. HVAC duct sizing tables are based on round duct sizes. For example, the hydraulic round duct size equivalent to a 22-inch by 22-inch square duct is 24 inches in diameter. The round duct has 6% less area and 17% less perimeter. The 24-inch diameter round spiral duct also is equivalent to a 35-inch by 14-inch rectangular duct or to a 60-inch by 10-inch rectangular duct. The 60-inch by 10-inch duct has 32% more area and almost twice the perimeter of the round duct. Based on industry duct construction tables, the long 60-inch span of the rectangular duct also substantially increases the thickness or gauge of the duct metal and the required reinforcement, which the round spiral duct does not need. When height restricts round duct size, multiple ducts of smaller diameters may be used. For example, two 18-inch diameter ducts have approximately the same static pressure loss as the single 24-inch duct for the same total airflow. Although the total duct area and perimeters may increase, the duct metal thickness or gauge may stay the same or actually decrease, reducing the weight of the individual round duct sections. The SPIDA brochure entitled Designer's Guide contains a sample variable air volume, often called VAV, supply air duct system, that furnishes 20,500 CFM of air at 3 inches water static pressure. Estimated costs for the use of 3 different types of ductwork were obtained from 9 qualified sheet metal contractors located in major cities throughout the United States and Canada. All duct sizes were based on ASHRAE equivalent sizes and all had approximately the same static pressure drop. The round spiral duct system construction varied in size from 32 inches diameter at the fan to 14-inch diameter branch connections. The flat, oval spiral duct system construction varied in size from 60 inches by 16 inches at the fan to 14-inch diameter branch connections. The rectangular duct system construction varied in size from 60 inches by 16 inches at the fan to 12-inch by 14-inch branch connections. As the plotted cost estimates indicate, dollar amounts varied widely from city to city. The round duct is indicated by the green line, flat oval by the blue, and the rectangular by the red. The type of shop fabrication equipment used also created variations in cost. Some of the reasons for lower costs of spiral duct systems is that spiral round and flat oval ductwork can be made in exact lengths and in longer lengths that are limited only to what can be handled and transported. Because round spiral duct is lighter, it is easier to handle and to install. And with longer lengths, there are less joints connecting the duct sections to leak system air. Using duct air leakage tables found in the ASHRAE Fundamentals Handbook, the duct seal class must first be established. Then, using the proper seal class in the air leakage class table, the duct air leakage rate for sealed spiral ducts is half that of rectangular metal ducts, under the same duct system pressure conditions and the same duct perimeters. Duct air leakage calculations for the 3 duct construction methods used for the sample VAV system require the use of square feet of duct surface. Note that the smaller perimeter of the round spiral duct discussed earlier now greatly affects duct leakage, because the perimeter multiplied by the duct length equals the duct surface. The ASHRAE duct air leakage table is based on 100 square feet of duct surface and the average internal duct static pressure. Duct air leakage calculations for the round spiral ductwork in the sample system total 338 CFM, or 1.68% of 20,100 CFM. Calculations for the flat oval ductwork in the sample HVAC system total 388 CFM, or 1.93% of 20,100 CFM. Calculations for the rectangular ductwork in the sample HVAC system total 887 CFM, or 4.41% of 20,100 CFM. Duct airflow heat gain or loss also is based on the amount of duct system surface, as well as other factors such as the temperature difference between the duct airstream and the surrounding ambient air, and the duct airflow velocity, which is a function of the duct cross-sectional area. The approximate duct heat gain calculations for the same sample HVAC duct system constructions follow below. Part of the heat gain came from a 90-foot section of round spiral ductwork wrapped with 2-inch fiberglass insulation, conveying 55-degree air through a 115-degree attic. The 32-inch diameter round spiral duct had a calculated heat gain of 23,825 BTU per hour. The 60-inch by 16-inch flat oval duct heat gain with the same 2-inch insulation was calculated at 32,820 BTU per hour. And the 60-inch by 16-inch rectangular duct heat gain under similar conditions was calculated at 43,100 BTU per hour, or an 81% greater loss of cooling capacity than that with the round spiral duct system under the same thermal conditions. If space was too limited to use the 32-inch round spiral duct, the use of smaller, multiple round spiral ducts with the same airflow requirements could be used. However, multiple ducts would have a higher cooling capacity loss through the attic than that with a single round duct. Other spiral duct advantages when used for HVAC system ductwork are ongoing duct system operational cost savings, as shown by examples in the Designer's Guide, prompt delivery, as spiral duct and fittings generally are stock items. Round spiral ducts need less reinforcement and less hangers because they're lighter in weight. Rumble or low-frequency noise in HVAC duct systems comes from fans and fitting air turbulence. Transmission loss is a measurement of the capability of an HVAC duct to contain or control noise from leaving the ductwork. The higher the transmission loss, the less the noise will radiate out from the duct. A comparison of transmission losses is shown for the 3 duct construction methods: for round spiral duct, for flat oval duct, for rectangular duct. Although rectangular ducts have a higher transmission loss at easier to attenuate higher frequencies that usually are generated by air terminal devices, the high transmission losses of round spiral ducts in the low frequency ranges are extremely important and useful. For example, one would hear a 125 Hz frequency fan noise of 100 decibels breaking out of a rectangular duct at about 77 decibels or 61 decibels above the human hearing threshold, which is moderately loud noise. The 100 decibel fan noise at 125 Hz would break out of a round spiral duct at about 50 decibels or 34 decibels above the hearing threshold, a quiet sound level where one should hear whispered conversation 6 feet away. Round spiral duct has been used extensively by architects and engineers, not only for its efficiency, but to create artistic effects. This is an HVAC spiral duct installation in a fun park, in a restaurant and bar, in an atrium, and as underground HVAC ductwork. In summation, the following are some of the reasons why spiral duct systems should be used. They are energy efficient, cost less to install, often require less space, need less hangers, have lower operating costs, radiate less system noise to the occupied space, and are lighter in weight. Don't forget, many of the advantages of using spiral duct systems featured in this video and other important information is found in the SPIDA Designer's Guide, available free of charge from SPIDA members. SPIDA has a free computer disk program that may be used to size round or flat oval ductwork, or convert rectangular duct sizes to round or flat oval sizes. It also contains sample specifications in the CSI or AIA formats. So, don't miss this opportunity to improve your design and installation of cost-saving and more efficient HVAC duct systems like these.